So this problem, we have the function g can be thought of as a scaled version of f of x equals x squared. So we need the equation for g of x. So the blue one is the parent function, and g is the new function that we need the equation for. Now notice the parent function goes through the point 1 comma 1, but the new function goes through the point 1 comma 5. And we could look at other values. It still goes through the origin. If you put in -1, parent function goes to the point 1, and g goes through -1 comma 5. Now, if we looked at 2, it goes through 2 comma 4, and you can't see it, but it seems to be that this one's heading for about 2 comma 20, which is 5 times the value of the parent function, because we know that this is 5 times greater. And this exercise is dealing with scaling rather than shifting. So we know we're not going to be adding or subtracting, that all of this is going to be achieved through multiplication. And since the y value is 5 times greater, we know that we're just multiplying our parent function by 5. If the y value was, let's say, 1 comma 1/3, then we would know that we're multiplying the parent function by 1/3. So in conclusion, we have that g of x is 5x squared. So let's do some more problems just to get a lot of practice on these. And in this one, we're given our parent function, which is going to be graphed in blue, and this other function, g of x, which is -1/2 x squared. So we want to think, what does this negative do, and what does the 1/2 do? So let me rewrite it. Now, the minus sign we know leads to a reflection. So we have a reflection, and that reflection is going to be across the x-axis. But we also have multiplication by 1/2. So the y values will be half of what they used to be, which is a compression. So it's going to compress by a factor of 1/2. So essentially it's going to become wider, and it's going to be reflected. So you can always eliminate some. It's not going to be in the same orientation. It's not going to be opening upward, and that eliminates b as well. Now, we do know it's reflecting, but it also should be wider because it's being compressed. So this one looks to be skinnier. It looks like you would be maybe multiplying by 2 rather than by 1/2. And this one makes it wider. So in this case, choice D would be the correct answer. So we got a parabola. They give us our parent function, y equals x squared. And it's reflected across the x-axis. So that's going to be multiplying by a negative number. And then it's going to scale vertically by a factor of 1/6. So essentially, all of our y values are going to be multiplied by 1/6. So let's write that down. We know we have the reflection, that's the negative, and the scaling factor, that's multiplication by 1/6. But we still have this x squared because we're essentially taking our parabola and transforming it. The negative will give us our reflection, and it's scaled vertically by this factor of 1/6, so that would mean all the y values are 1/6 of what they used to be. So we can put in -1/6 x squared. And I encourage you, check this with Desmos. Make sure that this makes sense to you before plugging in your answer to the exercise. So for this one, g can be thought of as a scaled version of f of x equals x squared. So we again have our parent function here, and notice that it's reflected, and it might even be a little bit wider. It can be kind of difficult to tell sometimes, but let's look at this key point that they give us and compare it to our parent function. So at a y value of 3 for our parent function, that looks to be up at 3 comma 9. So let's write that in. For our parent function, we're at 3 comma 9, but for this one, we're at 3 comma -6. So we want to think, what did we multiply this 9 by to get -6? Because we're comparing it to this parent function. And we know, first of all, since it's reflected, we're going to deal with a negative here. But we also need to figure out that scaling factor. And if it was just minus x squared, then it would go through the same y value but negative. It would go through at -9 right here, but it's less than that. So that means we multiplied by some type of fraction. And so we need to figure out that fraction. We essentially took that y value, which in our case was 9, and we multiplied it by some number. And I'll call it a, so we can solve for it. And when we multiplied it by that scaling factor, the new y value is -6. So for this, we can solve for a. Divide each side by 9, we get -6/9, which is -2/3. So compared to our parent function, this y value was multiplied by a negative number and multiplied by 2/3, since 2/3 of 9 is 6, and again, we have that negative sign. Now you can check this for other points, like for instance, maybe 2 comma 4. So when we multiply that by -2/3, we get -8/3, which would be -2.6 repeating. And so let's see if we roughly have that. It's a little difficult to tell, but you can approximate it. And here's -2, and it goes through right there. That looks to be about 2/3 of the way between -2 and -3. And if you want, you can check further points like -3. That would also give you -6 because of the symmetry. But again, plug this into Desmos. See if you do get back this exact curve. So our equation, g of x, would be -2/3. Let me use a different color. -2/3 x squared compared to our parent function.